Right, so we've talked about sediment being brought down to the beach by rivers. We've talked about sediment being washed along the beach by waves. We've talked about sediment being taken away from the beach through submarine canyons. And all of this plays into the sediment budget, right? It's how much sediment is in the coastal environment. What's bringing sediment in, what's taking sediment out, where's that sediment going? That's what creates the shape of our beaches. The sediment budget does. Right? So that sediment budget is washing around our beach. And as it does, it is creating different coastal environments, right? So the beach itself has many different sub-environments in it. The foreshore, also called the intertidal zone, that's the region between high tide and low tide. The beach face is the steep concave part of the beach that's formed by the wave swash. And then the back shore is the upper part of the beach above high tide, right? So beach face, steep part, foreshore between the high tide and the low tide, back shore away from the high tide, right? And sand and sediment is being transported in between those environments, and the shape of those environments is changing quite quickly. Okay? So one way that the shape of those environments can change is when longshore transport creates spits and bay mouth bars. So longshore transport is causing sediment to move along the coast, right? Ever so slowly, just grain after grain, but each individual grain adds up after a while. And it creates these almost like drool-like shaped sand features, right? Imagine like drool hanging out of your mouth, creating a spit shape. The same thing happens along our coast. As that sand moves along the coast and gets migrates away from the land, you get a spit, right? And if it breaks away from the land, then you'll get a bay mouth bar. So this is Jekyll Island on our coast. And remember, the spit is formed in the direction of longshore transport. So what is the dominant direction of longshore transport on our Georgia coast? We're looking at this. The part of the island that looks most spit-like is to the south, which means that the longshore transport is from north to south, which means that predominantly waves come in from north to south along our coast. And this is true for the entire southeast coast. Predominantly, the longshore drift is from north to south. And you can see this spit shape on almost all of our islands. Speaking of barrier islands are super cool. They're all along our southeast coast. And they are formed in a variety of ways, right? But a barrier island is basically just any island that's elongated and sits just offshore of the mainland. So it basically creates a barrier in between the ocean and the back barrier, the marsh, the lagoon, the mainland, hence the term barrier island. Now, on our coast, over the past thousands of years, about 7,000 years, Georgia's barrier islands have actually been able to build up and seaward. However, today, because of sea level rise and a lack of sediment, sediment's actually being stuck up on land more often because of human structures like dams, our beaches are becoming starved of sediment and actually starting to erode and retreat back landward. All right, so a few other coastal landforms I want to talk about. One is tidal flats. So our marshes are covered in vegetation, but if you travel past our marsh when the tide is really, really low, you'll see vast expanses of mud that are exposed during low tide, and we call those tidal flats. They're accumulations of mud and silt. They're really sticky. If you go in there, you can get stuck up to your knees in the mud, but they're really important ecosystems, and they usually support a large population of wildlife, including migratory birds and crabs and mollusks and fish. So tidal flats are very important to the coastal ecosystem health, as are estuaries. So estuaries form where rivers meet the ocean, where freshwater rivers meet the saline ocean, and they mix together to form what we call brackish. Not quite fresh, not quite as saline as the ocean, brackish water. That's the estuary. Right? And this is also where we get a lot of thriving ecosystems. It's where a lot of nursery habitat is, right? So the baby animals that need a safe, nutritious place to stay before they grow up and migrate out back to the open ocean. Okay, so along our coast, where do you think we might have our estuaries? Well, I see the Altamaha coming into the Atlantic Ocean. That's going to be an estuary, as well as all of the other smaller rivers around here, where the rivers meet the ocean, and that's normally happens in between our barrier islands. We get an estuary. We also have very organic coasts, meaning that there's just a lot of organic material here. We've got marsh grass, we've got vegetation, we've got vegetated wetlands, right? Trees, mosses. We don't have mangroves here, but a lot of places have mangroves, right? So they're going to be the trees that grow in that intertidal zone. So we call them the organic coasts because there's just a lot of highly productive biological ecosystems.